Hi guys, so today is the day 11 of the September LeetCoding challenge, and this is the problem we have to solve on this day 11. So like in this problem, like we have been given a string as representing a valid expression, and we need to implement a basic calculator to evaluate it. So basically there will be an expression given in the form of string, and we need to like find the result of that expression. So if 1 plus 1 is given, so 1 plus 1 is 2, so that's why it is 2. And here like 2 minus 1 plus 2, so 2 when subtracted with 1 will give 1, and then 1 when added with 2 will give 2 3, so the answer is 3. And similarly this is a complex expression involving parentheses, and yeah, so this whole expression will result in 23, so the output is 23. And we are given that the length of this string as is up to, like, the maximum length can be 3 into 10 power 5, and s only consists of plus, minus, opening parenthesis, closing parenthesis, and an empty string. So throughout the problem we can ignore this empty string while processing the string. So this, like, ignoring this thing won't cause any problem, so we just have to ignore whenever we are encountering such character to solve this problem. And it has been given that positive, like this plus, is not used as an unary operation. So basically wherever this plus is occurring, it is only working as an operator, and minus can only be used as a unary operation if it is inside parentheses. So like suppose we are like somewhere like we are saying that we have to add 4 with minus 4, so like we have to enclose this the minus 4 term inside a parenthesis. And yeah, there will be no consecutive operators in the input, so we won't encounter any two consecutive operators in the input. So we want to see something like that, plus minus 4. So there will be only plus 4 or minus 4, and every number and the running calculation will fit in a signed 32-bit integer. So basically this means that we are like we can freely use integer data type to solve this problem. So let us try to understand how we'll be solving this problem. So what I will be doing, I'll be making a recursive function, because like there are parent in, like there are complex expression as well. So what this recursive function will do, like this recursive function will take a starting index and ending index, and it will evaluate the expression from the starting index to ending index of this string. And how this recursive function will work. So basically what I will do, I will first store the index of the ending, like closing parenthesis, for every opening parenthesis using a stacks. And I will make an ordered map that will store the index of the closing parenthesis for every opening parenthesis. And suppose I am scanning through, I will start scanning from left to right, and I will have a variable for storing the value of the overall expression, and I will have a variable that will tell me that whether the, like suppose there is a negative in front of this whole expression enclosed inside parentheses. So whatever this, the value of this expression that will be enclosed inside the parentheses will be, so that value needs to be subtracted to the overall value of this expression. So I will have a variable that will tell me that whether I have to subtract this expression, or like subtract the value of this expression, or add the value of expression to the overall value of this whole expression. And I will just scan from the left, and whenever I will like encounter a positive, whenever I will encounter a negative, I will like set that sign as negative, and whenever I will encounter a positive operator, I will set the sign as positive. And suppose I will encounter a digit, then I will keep forming, I will like keep iterating until I am encountering digits, and I will form a whole number with it, and whatever the sign will be, like I already have a variable for indicating the sign, and so whatever the sign will be of the very at the like whatever will be the sign whenever I was encountering this digit. So after making a number out of this long chain of digits, I will add or subtract, the value into the overall expression. And if suppose I am encountering opening parenthesis, then I will taking the opening parenthesis and closing parenthesis, and I will again call a recursive function on this part to get its value, and whatever will be the value of the sign at that present at that instant. So according to that, I will add the value obtained from after calling the recursive function, or subtract the value of the recursive like returned by the recursive function to the overall expression. So like seeing the implementation, you will understand what exactly I will be doing it. So first of all, I can reset it. So first of all, like we'll be storing the closing parenthesis for every opening parenthesis. So I'll be using a stack. So this stack will only contain, like whenever we will encounter a opening parenthesis, we will push its index in the stack, and whenever we will encounter a closing parenthesis, we will pop the stack at the top of the we will pop the stack to get an index, and that index will be like the current I of the closing parenthesis will be stored. Like I will be using a map. I mean that I will be using a map, and this what this map is doing. So it is mapping the index of opening parenthesis to closing parenthesis, and I can call it pairs. So whenever I will encounter a opening parenthesis, I will push it on this stack, and whenever I will encounter a closing parenthesis, then I will pop the opening parenthesis corresponding to this closing parenthesis, and then I will assign the index of the closing parenthesis to this opening parenthesis in this unordered map. So I'll be using this unordered map for like calculating the value of the expression. So whenever I'll be encountering opening parenthesis while processing this string, I will take the whole string starting from the opening parenthesis to ending parenthesis and call the recursive function on it and retrieve its value. So that is the purpose of doing this thing. So we can start from integer I equal to 0 and I less than s dot length. So if we are encountering a opening parenthesis, then we need to push it on the stack, and whenever we are encountering the closing parenthesis, then we need to set the then we need to map the topmost element present in the stack to the current I, and we also need to make sure that we are popping this stack. So yeah, only these two characters matter for us because all other characters are not going to affect the calculation of this thing. So this whole loop will calculate the pairs, and now we can call a recursive function. So this recursive function will take the starting index, the ending index, the string as because this, so that it can make like calculate the expression, and it will also need this pairs unordered map. So we have called this function. Now we need to declare this function. So I'll be declaring this function. So this function will be returning the int, and this is the opening index, like starting index. This R is the ending index. I'll be passing the string by reference, and I'll be passing this unordered map by reference to. Now we need to iterate over the string. First of all, I will declare a variable for storing the overall value of this expression. I will also have a variable for indicating the sign of the current block of expression. So I will like suppose if it is 1, then we are adding that expression, and if it is -1, then we are subtracting the expression. So after calculating the value of a block of expression, I'll be multiplying this sign. I'll multiplying that value, calculated value, with sign, and then adding it to val. So this is the plan. Now we need to iterate over the part of the string. So I will be starting from L and ending at R. First of all, we can check whether the S of I is opening parentheses or not. So if it is opening, then we need to find the closing index of this opening index. So how can we do it? We already have a unordered map, and doing pairs I will give us that. So now we need to find the value of this whole expression. So suppose this is the opening parenthesis encountered, then this is the corresponding closing parenthesis. So we need to calculate the overall value of this whole part. So how can we do it? We can call this recursive function. So this recursive function is calc. So it will take the opening, like starting index and ending index. So I'll be doing I plus 1 and pairs I minus 1, because like we only need to calculate the value of the expression inside this whole parenthesis thing. So that's why I'm doing I plus 1 and pairs I minus 1. And then we need to pass the string as and the unordered map. So this will give us the value of this whole part, like small part. And now we need to add it to val after multiplying it with the sign. And we also need to make sure that we are doing I minus minus. No, I minus. First, we need to set this I equals to pairs of I, right? And after we will set it to pairs of I, then yeah, it should work. So after we will set it to I equal to pairs of I, then after execution of this loop, this I will get incremented, and then this whole processing will continue. Now we need to make sure, like we need to update sign if we are encountering a positive operator. So sorry guys, it should be plus. So if we are encountering a positive plus operator, then the sign should be 1. And if we are encountering a minus operator, then the sign should be -1. And now the only case is that when we are encountering a digit character. So if SI is greater than equal to the character representing 0, and SI is less than equal to character representing 9, then that means that the SI is representing a digit. Now we need to form the number corresponding to this, like starting at this digit. So we can do it until I is less than R, and if this SI is not a digit character, so if this SI is a digit character, then we need to multiply this num into 10 and add the current digit. So current digit will be obtained by subtracting the zero digit, like this character representing the 0 digit with the current digit. And in case we are encountering something else, then we need to break. And we also need to make sure we are doing I minus minus, because like we want the character that we are encountering to be processed after this in the next iteration. So that's why we are doing I minus minus, because like after this whole thing inside this for loop, the I will get incremented. So if we are not doing I minus minus, the character we just encountered will be missed. And yeah, first we need to make sure we are doing I minus minus before breaking. Otherwise, this I minus minus won't execute. So after execution of this for loop, we will have this num. So this number thing, and we can multiply it with sign and then add it with val. So yeah, this whole for loop will process the string. In the end, we just need to return the val. So let us see whether we have some compilation error or something or not. So we can run this code. Yeah, it's working on the sample test case. We can submit it. Yeah, it got accepted. So see you guys on day 12. Until then, keep LeetCoding.